What if I told you that Amish gardens produce more food after 100 years than they did in year one? That their soil gets richer every season while conventional gardens deplete and require increasing fertilizer? Traditional Amish soil building refined over 300 years creates permanent fertility that compounds across generations. And today I'm going to show you 10 methods. Continuous compost application. 2 to 4 inches of finished compost applied annually builds organic matter by 0.5 to 1% per year, transforming average soil within a decade. Amish families maintain multiple piles in various stages, ensuring constant supply. Materials include kitchen scraps, garden waste, aged manure, and fall leaves. Spring application before planting incorporates nutrients for the season, while fall application protects soil through winter. Results show organic matter building from typical 2 to 3% to 5 to 10% after consistent application. Traditional philosophy follows feed the soil, not the plant. Aged animal manure. Integration. 6 to 12-month composted manure provides balanced, slow-release nutrients without burning plants or introducing pathogens. Fresh manure is too hot and harbors weed seeds that aging eliminates. Amish farms produce manure from horses, chickens, and occasionally cattle. Application involves working 1 to 2 inches into beds 2 to 3 weeks before planting. The NPK profile provides slow-release nutrition over months rather than synthetic spikes. Bonus benefits include billions of beneficial microbes, significant organic matter, and trace minerals including calcium, magnesium, and sulfur. Your soil becomes a living ecosystem. Cover crops. Every winter, planting cover crops immediately after harvest prevents erosion while adding biomass and fixing nitrogen. Common Amish choices include winter rye for deep roots, crimson clover for nitrogen fixation, and hairy vetch for maximum nitrogen contribution. Bare soil erodes in winter rains and loses nutrients to leaching. Timing sows crops August through October with termination March through April. Deep roots break compacted layers and mine subsoil minerals. Traditional wisdom considers bare soil wasteful. Results show 30 to 50% yield increases in following crops. Cost is $10 to $20 per 1,000 square feet. Minimal tillage. Philosophy. Disturbing soil only when necessary preserves structure and protects biological communities that create fertility. Heavy tillage destroys aggregates, kills beneficial fungi, and oxidizes carbon by exposing organic matter to air. Amish practice uses shallow cultivation with wheel hoes, hand tools, and broad forks rather than deep plowing. Traditional wisdom states the less you disturb, the more it produces. Modern no-till research confirms soil biology requires stable habitat. The exception is initial bed preparation, but ongoing cultivation stays minimal and shallow. Soil structure remains intact with channels for water and roots. Mulch. As permanent layer, 2 to 4 inches of organic mulch maintained year-round provides multiple benefits including moisture retention, weed suppression, temperature regulation, and continuous soil feeding as materials decompose. Materials include straw for vegetable beds, leaves abundant and free in fall, grass clippings from lawn maintenance, and wood chips for pathways. Application occurs after planting once plants establish, with refreshing as decomposition reduces depth. Traditional Amish saying declares, bare soil is dying soil, because exposed earth loses moisture, erodes, and bakes in sun. Temperature regulation keeps soil cooler in summer heat and warmer during cold snaps, protecting soil biology. Biology thrives under mulch with habitat for beneficial organisms including beetles, spiders, and microbes. The long-term effects see mulch gradually becoming humus that builds topsoil depth measurably over years. Your soil surface becomes protected living layer rather than exposed vulnerable crust. The manure compost staging system. Transforming raw manure into a stable nutrient source through systematic aging prevents plant burning and pathogen transmission while creating a biologically rich amendment. Fresh manure contains ammonia that burns roots, weed seeds, and pathogens, including E. coli and Salmonella. The aging process uses composting where hot phase temperatures reaching 130 to 160 degrees kill weed seeds and pathogens. Cool phase allows beneficial microbes to colonize the material. The Amish 3-bin system maintains continuous supply. Bin 1 receives fresh manure and bedding added daily from horses and chickens. Bin 2 holds actively composting material about 6 months old, turned weekly. Bin 3 contains finished compost ready to apply. The continuous rotation ensures finished compost is always available. Temperature management requires monitoring with compost thermometers, turning piles when temperature drops below 100 degrees. Multiple heat cycles ensure complete processing. Moisture content aims for damp sponge consistency because too dry material stalls decomposition, while too wet creates anaerobic conditions. Carbon-nitrogen balance determines composting success. Manure provides high nitrogen while straw, leaves, and wood shavings contribute carbon. The ideal ratio is 30 parts carbon to 1 part nitrogen. Amish horse manure is particularly valuable because it's cooler than cow manure and contains high carbon from bedding. Mixed with nitrogen-rich chicken manure, the combination creates perfectly balanced fertilizer. Application method spreads 1 to 2 inches on beds in fall, allowing winter weathering to mellow it further. Spring incorporation works material into the top 4 to 6 inches before planting. The nutrient profile approximates NPK 111, but the slow release over months provides steady nutrition rather than synthetic spikes. Trace minerals, including calcium, magnesium, and sulfur, come with billions of beneficial microbes per gram. Traditional practice refined over 300 years created reliable systems. Modern comparison shows synthetic fertilizers provide fast nutrient spike that depletes soil biology and leaches easily, while aged manure feeds slowly and steadily. Results over 10 years build organic matter from typical 2 to 3% to 5 to 8%. Implementation starts with a small bin and gradually adds manure sources. Crop rotation for soil building. Different crops contribute different benefits through varied nutrient requirements, root structures, and biological partnerships. Heavy feeders, including tomatoes, corn, and squash, extract significant nutrients. Light feeders like root crops require minimal nutrition. Soil builders, primarily legumes, actually add nitrogen through atmospheric fixation. Different root depths access different soil layers with shallow crops working the top 12 inches while deep taproots penetrate 3 feet or more. The Amish 7 to 10 year rotation systematically cycles crops through beds. Year 1 plants heavy feeders requiring peak fertility. Year 2 transitions to root crops needing less nutrition. Year 3 establishes legumes whose nitrogen fixation rebuilds fertility. Year 4 plants brassicas benefiting from added nitrogen. Year 5 uses alliums as light feeders. Year 6 and 7 may include cover crops or fallow periods. The cycle then repeats in different beds. Nitrogen fixation specifics show legume roots hosting rhizobium bacteria in visible nodules. These bacteria convert atmospheric nitrogen gas into ammonia. Active nodules appear pink inside when sliced. The process adds 100 to 200 pounds of nitrogen per acre. Chopping plants before flowering releases maximum nitrogen to following crops. Root depth diversity creates fertility at all levels. Shallow crops work 6 to 12 inches. Medium depth crops reach 18 to 36 inches. Deep crops extend 36 to 48 inches. Taproot cover crops penetrate 10 feet or deeper. Each depth accesses different soil layers. Root exudates feed specific microbe populations. Plants release sugars, organic acids, and enzymes from roots. Different crops release different compounds, supporting diverse microbial communities. Brassicas accumulate sulfur during growth, releasing it as residues decompose. Traditional Amish record keeping uses written maps passed to children. The soil health trajectory shows years 1 through 3 stabilizing fertility, years 4 through 7 actively building, and year 8 onward maintaining peak fertility. Implementation maps your garden and plans a minimum 4 to 7 year rotation. Cover crop cocktails. Multiple species planted together create benefits greater than the sum of individual species through complementary functions. Different plants contribute different root structures, from fibrous networks to deep taproots. Different root depths build soil at all levels. Different functions include nitrogen fixation, biomass production, mineral mining, and pest cycle disruption. The traditional Amish winter mix combines 40% winter rye for deep roots and massive biomass, 30% hairy vetch for nitrogen fixation and winter hardiness, 20% crimson clover for nitrogen fixation and early spring bloom, and 10% turnips or radishes whose taproots break compaction then die over winter. Planting strategies sow seed August through October after harvest by broadcasting or drilling, followed by light raking. Growth continues through fall, plants over winter, then resume vigorous spring growth. Rye shows rapid fall growth, winter dormancy, and vigorous spring resurgence. Vetch grows slowly in fall, overwinters as small plants, then explodes in spring. Clover establishes in fall and blooms in early spring. Radish grows vigorously in fall, then dies over winter. Termination timing is critical. Mow or cut when vetch begins flowering, usually late April or early May, capturing maximum nitrogen in plant tissue. Let chopped residue sit on surface 2 to 3 weeks before planting. Incorporation methods vary by philosophy. Traditional shallow tilling 3 to 4 inches incorporates material directly. Modern no-till mows and leaves as surface mulch. Broad forking loosens soil without inverting layers. Chicken tractors scratch through residue, accelerating decomposition. Nutrient contribution includes 100 to 200 pounds nitrogen per acre from legume fixation and 3,000 to 5,000 pounds dry matter biomass per acre. Traditional practice shows every Amish garden includes cover crops as non-negotiable soil building. Implementation starts with a simple rye vetch mix, expanding to more complex cocktails. Deep composting in trenches. Burying organic matter in trenches builds subsoil fertility that surface composting cannot achieve, creating deep rooting zones with concentrated nutrients and moisture. The method digs trenches between rows, fills them with organic matter including kitchen scraps, garden waste, and manure, then covers with soil and plants directly over them. Historical context traces to hugel culture, the German mound technique. Amish adaptation uses trenches instead of mounds because they're less visible and more practical. Trench construction digs 12 to 18 inches deep and 12 inches wide, running between garden rows with spacing every 3 to 4 feet. Layering strategy places coarse material like corn stalks at the bottom for structure. Middle layers use mixed organic matter including kitchen scraps and garden waste. Top layer adds manure or finished compost. Covering with 4 to 6 inches of soil prevents odors. Materials that work include vegetable peelings, coffee grounds, eggshells, spent plants, weeds before seed set, any manure, and leaves. Avoid meat, dairy, and oils that attract animals. Decomposition begins anaerobically, then gradually becomes aerobic as worm channels develop. Within 6 to 12 months, materials fully decompose into stable humus. Root response shows plants seeking fertile trenches with concentrated growth in enriched zones. Water retention in decomposing organic matter creates reservoirs, reducing watering needs by 30 to 50%. Long-term soil building makes each trench a permanent fertile layer. Rotating trench locations yearly means after 5 to 7 years, the entire garden has deep fertility. Topsoil depth increases from standard 6 inches to 18 inches or more. Implementation starts with one trench to observe results, then expands. Integrated animal systems for fertility. Animals function as fertility engines that transform crop residues into concentrated manure, creating closed-loop systems where nothing is wasted. Animals consume crop residues that would otherwise compost slowly. They transform low-value plant material into high-value manure through digestion. Manure feeds soil biology with nutrients and microbes. Improved soil grows better crops. The cycle continues indefinitely, improving with each rotation. The Amish chicken tractor system uses mobile pens moved daily across the garden. Chickens eat pests including beetle larvae and caterpillars, consume weed seeds before they can germinate, and process crop residues into fine particles. They deposit nitrogen-rich manure while scratches soil, aerating and incorporating materials. And pre-planting deployment for 2 to 3 weeks sanitizes beds of overwintered pests. Post-harvest chickens clean up residues and fertilize for the next crop. Horse integration provides field power through cultivation while producing prodigious manure. Horses produce approximately 50 pounds of manure daily. A family with 2 horses generates 18 tons annually. This manure moves to the composting system described earlier. Bedding including straw or wood shavings adds essential carbon. Horse manure is cool temperature, making it safe for gardens without extended aging, though aging improves it further. Sheep and goat rotational grazing uses small ruminants to graze cover crops before termination. They deposit manure while grazing, fertilizing the soil. Hooves press cover crop seeds into soil contact, improving germination of any volunteer regrowth. Trimming prevents cover crops from going to seed prematurely. Animals remove before main crops are planted. A rotational sequence example shows the system in action. Spring harvests vegetables from beds. Early summer plants buckwheat cover crop for weed suppression and pollinator support. Midsummer runs chickens through after buckwheat flowers, incorporating it while adding manure. Late summer sows winter cover crop mix. Fall and winter allow cover crops to grow and build biomass. Early spring briefly introduces sheep to graze cover crops, adding manure. Spring mows remaining cover, runs chickens through the residue, then plants main crops. Manure nutrient contribution varies by animal. Fresh chicken manure provides NPK 321 with very high nitrogen. Aged horse manure offers NPK 111 and balanced profile. Combining them creates approximately 2 to 1.5 to 1, ideal for vegetable production. Slow release feeds plants for 6 to 12 months rather than washing away. Biological inoculation occurs because animal manure contains billions of beneficial microbes per handful. This introduces diversity to soil biology. Gut microbes from animals colonize soil, bringing new species and genetic diversity. Enhanced nutrient cycling results from more diverse microbial communities. Traditional Amish integration includes multiple animal species on every farm because each contributes differently. Horses provide power and manure. Chickens produce eggs, control pests, and provide manure. Occasional cattle or sheep offer meat, grazing services, and manure. Labor efficiency improves because animals perform work humans would otherwise do, including fertilizing, tilling through scratching, and pest control. Nutrient cycling operates automatically. Scale considerations show small gardens needing only 3 to 5 chickens for significant benefit. Large gardens benefit from chicken tractors plus rabbit manure. Homesteads incorporate horse or cattle manure that's been properly aged. Modern application without owning animals purchases aged horse manure from local stables, uses chicken manure from small backyard flocks, or sources rabbit manure which is cold and requires no aging. Results over 10 years transform soil organic matter from typical 2 to 3% to 7 to 10%. Yields double or triple compared to initial production. Pest and disease pressure decreases 70 to 90% as soil health improves. Input costs approach zero for ongoing production. Soil health shows compounding improvement, getting easier and more productive annually. Implementation starts with a small chicken flock or sourced manure from local farms, building the system gradually as skills develop. These 10 Amish soil building methods prove that fertility is not something purchased annually, but something built permanently through intelligent systems. 300 years of refinement created techniques where soil improves every year rather than depleting. The foundation combines continuous compost, aged manure, winter cover crops, minimal tillage, and permanent mulch. Deep systems including manure composting, crop rotation, cover crop cocktails, trench composting, and animal integration compound these benefits. The results are measurable, with organic matter increasing from 2 to 3% to 7 to 10% over a decade. Topsoil depth doubles from 6 inches to 12 inches or more. Yields increase while inputs decrease. Pest and disease problems diminish annually. You don't need to be Amish to apply these methods. Start with compost and cover crops. Add aged manure and reduce tillage. Build systems that improve soil rather than mining it. Your great-grandchildren will inherit better soil than you started with, which is the true measure of success.